Hello everyone, welcome to my channel. I have observed so many students struggling with differentiation. So here I am starting a series of sessions for differentiation. If you find these videos useful to you, please like and subscribe this channel and don't forget to press the bell icon. Before starting the session, please note down these two formulas. These are two crucial formulas for differentiation using definition. We are going to discuss these formulas later on. Here are the notations. See, what is differentiation? Differentiation is nothing but change in one quantity with respect to some other quantity. If I have two quantities, suppose U and V, so change in U with respect to V will be given as du by dV. Here d by dV is the operator. That means we are calculating change in some quantity with respect to V. Okay, suppose I have a function g of x, that means g is dependent on x. If x will change, g will also be changed. So rate of change in g with respect to x. With respect to x means the operator will be d by dx. So d by dx of gx is the derivative of g with respect to x, which gives us the rate of change in g with respect to x. Right? So these are the notations that d by dx of fx is derivative of f with respect to x. This also can be written as f dash of x, or if y is a function of x, that means y is given by fx, then derivative of y with respect to x will be given by y1 or y dash. So these are the notations. Now the formulas. There are two formulas for differentiation using definition, but the second formula is a modified formula which is obtained from the first formula only. So first of all, let us see how the second formula is derived. In the first formula, if I replace t minus x by h, then what will happen? The limit t tends to x will be changed to t minus x tends to 0. But if I am taking t minus x equal to h, then it means h tends to 0, right? Moreover, t minus x is equal to h means t is nothing but x plus h. Now look at this first formula. The formula is limit t tends to x, ft minus fx upon t minus x. Here the limit is changed to h tends to 0. In the numerator, t is replaced by x plus h, and in the denominator, t minus x is replaced by h, and hence the second formula. That means if you understand the first formula, the second formula is automatically understood. We don't have to memorize these formulas, right? Now, when to use which formula? So first of all, there is no bound in using the formulas. We may use any of the formulas for all the functions, but thing is that the second formula is a modified formula which makes the process easier when we are dealing with trigonometric functions and exponential functions. For example, I have written some examples here: x raised to x, a raised to x, sine x. That means the trigonometric functions sine, cot, tan, cot, sec, cosec, and the exponential functions like x raised to x, a raised to x, or e raised to x. So remember that when we are dealing with these kind of expressions, we will use the second formula, which is the modified formula. Let us take an example here. I want to differentiate x cube plus 3x square minus 5. See, there is no trigonometric term, no exponential term, and therefore I will use the first formula, right? What is the first formula, guys? It is limit t tends to x, ft minus fx upon t minus x. So I want f of t along with f of x. So how to write f of t? Just replace x by t. Okay. Now I will replace ft and fx with these expressions in the formula, and therefore I am getting this. Now guys, don't forget that whenever there is minus in between two brackets, this minus will go inside whenever I will open the brackets, and these signs will be changed. Okay, that means if minus go inside, this will be minus and this will be plus, like this. Now plus 5 minus 5 cancelled out. I will write t cube and x cube together, t square and x square together, like this. Now it is easily seen that these 3 can be taken as common, like this. And this expression can be written as t cube minus x cube divided by t minus x, and t square minus x square divided by t minus x. Now here the limit formulas come. See, we have to understand the structure, okay? The formula is limit x tends to a, x raised to n minus a raised to n upon x minus a, which is equal to n a raised to n minus 1. Now what if I replace x by t? If I replace x by t and a by x, then the formula will be limit t tends to x. This will be t raised to n minus x raised to n upon t minus x, and the answer also will be changed to n x raised to n minus 1. That means I will get the answer in terms of x. Okay, like this, see. So these formula I am going to use, which is nothing but the formula I have just replaced the variables and constants. If I take n equal to 3, n is equal to 3, the answer is n x raised to n minus 1. That means this will be 3x raised to 3 minus 1. This will equal to 3x square. Okay. And if I take n is equal to 2, it will be 2x. These two expressions are going to be used here. And therefore I am getting the answer 3x square plus 6x. I hope you all have understood the example. In next section, we will take an example for the second formula. That means we will use the modified formula to solve the example in next session.